Okay, the inside of a funnel, keyword inside, of height 10 inches. So the funnel, I draw a picture here. So the funnel is 10 inches high. Inches. Has circular cross sections. Now that makes sense. This is a circle. If I look at the top of a funnel, as shown in the figure above, at height h, here's h, the radius of the funnel is this formula. So the radius is different at different heights. The height varies from 0 to 10. Makes sense. Units of R and H are inches. Okay. The funnel contains liquid that is draining from the bottom. So this is the liquid, and it's draining out the bottom. At the instant, so at a moment when the height, so the height is changing the whole time, because the liquid is draining, so the height is going down. But at the moment when the height is 3, the radius is decreasing at this rate. I'd write that down. So you've got amounts here and rates they're starting to talk about. So there's an amount, there's radius is an amount, height is an amount. There's a moment when the height is 3. The height is not always 3. Therefore we have rates. This is looking like a dread problem. So this would be dr dt. And they said at the moment when the height is 3, the rate for the radius is decreasing. Key word, got to read slower. This will be negative 1/5 inch per second. So the radius is going down by 1/5 of an inch every second, or by 1 inch every 5 seconds. At that moment, what is the rate of change in the height? So it's definitely related rate because we've got our rates. There's dH dt, that's what we're looking for. So we've got our Organicus chart. We've read the problem. We've found all the rates. We've got our amounts listed out. We need to find an equation that uses the amounts. They gave us that. It's right here. We just need to take the derivative of that equation with respect to time. So we have R equals 1/20, 3 plus h squared. So now I take the derivative. So dr dt, 1/20 is a multiplying constant. 3 and h squared are adding, so that becomes derivative of 3 is 0, plus this would be 2h dH dt. The goal of the problem is to find dH dt, so now I just rearrange everything and plug in things now that I've finished using the rules. So we're going to have dH dt is negative 1/5. Don't forget the negative. It's going to equal 1/20, parenthesis, to the height at this instant we are interested in is 3. dH dt is what we're solving for. So now just algebra. I'm going to multiply both sides by 20. So I'm going to get, I don't have to simplify anything, so you get negative 1/5 multiplied by 20. I would have then divided both sides by 6. And I get that. Double checking the answer here to make sure haven't made some mistake. Yes, this is correct. They don't require units to be listed, so we're okay with that. I would stop here. If you kept going, the reduced answer would be negative 2/3 inches per second. How fast the height is changing. I don't need to go that far. So I'm going to stop here and get 1 point. This green line is worth 2 points, right there. If you did part of that correctly but made a mistake, they'd probably give you 1 point. So it's 3 points total. So if you take the derivative of this and make an error, most likely you forget the chain rule right here. I'd say they'll give you one of the 2 points. If you get to this green line successfully, they'll give you both of those 2 points. And if you get to here successfully, they'll give you the 3rd point.